Okay, today we're going to go through the review for the limits test that's this coming week. So we're looking at first putting them into charts. We're going to create a table to evaluate the following limit. So this one says f of x is going to 2. So you're trying to find the limit of f of x as x goes to 2. So we're going to zoom in just a little bit more. Whoa, that's a lot bit more. Okay, so number 1, as we come down from the top, it gets closer and closer to 2, and as we come up from the bottom, it gets closer and closer to 2. So between here and here, we see that it's in between here and here. And as we go down further and further, this would come out to be closer and closer to 6. So our answer is 6 for the limit. Okay, so you could put some more parts to your chart if you wanted to. And at this point, the next one we would put in would be 1.9999. And then we would put in 2.0001. And then we'd see what those two numbers look like. But as you go closer and closer together, then it's going to get closer and closer to 6. Okay, number 2. So number 2, the limit as x goes to 3 of g of x. So g of x is on the top, and it's like the y value. And we're going to 3. So from the bottom, we're going up, going up, going up, and then we stop right here. Now you're going to see that it's 6 and negative 6. So since they don't match each other, then this is going to be a D and E, does not exist problem. Because if you think about what the graphs looked like when we were graphing the graphs, when they came together and they didn't touch each other, then we knew that was D and E. The next one, you can see that it says find the limit as x goes to 2 of f of x. So this one, as we get closer and closer to 2, then it goes up to 1,000,000. Well, if we did again the 1.9999 and the 2.0001, now obviously we can't do that because we don't have f, but the chart told us what's going to happen. So see how it's starting to go up small, and then all of a sudden it just boom goes up big. So where is it approaching? It's approaching infinity. Okay, the fourth one is the table that we're supposed to evaluate ourselves. So we're going to make a chart just like we had on the other ones. So we're going to have a chart that has an x, and ours is going to be called f of x. So now we're going to put in the things that closer and closer to 4 this time, because x is on the way to 4. So we have 3.9, 3.99, 3.999, 4.001, 4.01, and 4.1. Now we take those numbers and we plug them into the fraction. One of the things that I would encourage you to do is when you do plug it into the fraction, make sure the x squared plus 1 is in parentheses in the denominator when you plug things in, because if you're not careful, then it's going to take it and divide by x squared, and then it's going to add 1 instead of putting the whole thing is in the denominator. So we plug it into our calculator and we get numbers such as 0.2405, 0.2358, and you can go out further if you want to, 0.2353, and 0.2352, 0.2348, and the last one, 0.2302. So again, you get all those numbers by plugging it into the fraction. So now we're going to again do the same thing we did before. We're going to start at the top and we're going to get closer and closer to 1, which is between here, 3.99 and 4.01. So you can see how these two are really close to each other. So we get our fraction for the limit to be 0.23525, and that would be my limit. Now, one of the things you can also try is see how close this number right here is to if I just plug in a 4. So if I plug in 4, I get 4 over 16 plus 1 is 17. And then we can take and compare these two numbers. So if I take 4 and divide by 17, you're going to find that it's very close to this number. Okay? All right, the next one we're going to do is the graphs on number 5. Now, each of you should have this also in your Google Classroom, so that if you can't see it very well, then you should be able to see it from Google Classroom. So it says, use the graph below to evaluate the following limits. So this right here is the limit as x goes to 2 from the negative side of f of x. So we're going to drag ourselves from the negative side, so here's the negative side, and it says going to 2, so we're going across and we stop at 2. So we check the y value when we get to 2, and we see that the y value when I'm at 2 is 0. So my limit as x goes to 2 from the negative side of f of x is 0. Then I come again from the positive side. So I'm going the same thing from x being in the positive side of 2. So coming in, and so then I again get there, and my limit is going to be 0 as well. Now, this one goes from both sides because it doesn't have a positive or a negative side. So from the right or from the left, it's going to come from both. So if I come across this way and then I meet at 2, then we know that my answer is going to also be 0 for the limit as x goes to 2. All right, the next one we're looking at is D. So the limit as x goes to infinity, positive infinity this time. So as I'm going to positive infinity, so I'm going across to x, going to positive infinity, what's my y doing? My y is going up to positive infinity as well. So my answer for my limit is going to be equal to positive infinity. Now, one of the things that this doesn't show accurately is that this is also going to have an asymptote at -1, so this is an asymptote. So now the question says, if I go to negative infinity now, so as I'm coming down here and going to negative infinity, since it's an asymptote, I'm approaching and approaching and approaching. As I go to negative infinity, I'm getting closer and closer to -1. So my limit as x goes to negative infinity is -1. I'll try to be more specific when I'm doing the test to make sure that I have asymptotes marked. Okay, the next one is number 6. Number 6 says use the graph below to evaluate the following limits. So we have the first one is the limit as x goes to 2 from the negative side of g of x. So this is our picture of g of x. So we're coming from the negative side going towards 2. So as I'm going towards 2, then this is coming down. And then I'm stopping down here at -2. So this would be my y value for that 2 right there. So this one's going to be -2. Now this one says the limit as it goes to 2 from the positive side. So the positive side, then I'm coming around here, going across my x-axis, going towards the 2. So this would be my function, and it stops at +2. So from the right, -2, from the left, +2. So since they don't touch each other, then we know that's a what? That's a D and E. Does not exist. Okay, number 7. this one, we weren't sure. Some of us think there's an asymptote, and some of us don't think there is. But in this case right here, some people have read that as an asymptote instead of going on to infinity. So we'll just see what we got here. So number 7 says, use the graph below to evaluate the following limits. So the first one, A, says going to 2 from the negative side. So going to 2 from the negative side. I'm coming across this way. And then what does it do? At 2, it goes down to -1. So my first answer is -1. The B one says I'm going to x to 2 from the positive side. So again, I'm going from the positive side, this is my positives, and then it's jumping down to -1 also for that. So we have -1. Now, since both of them come together from the right and from the left and then the right, then we go both together, so we know that that one's also going to be -1. Not a D and E situation because it comes down. Okay, the next one says it's going to -1 from the negative side. So if I'm going from to -1 from the negative side, then you can see here that would be -1 coming from the negative side is also going to be -1. Good job. Okay, the next one says going to -1 from the positive side. So if I'm going across my number line, I go to -1 from the positive side. That would be this side then. And it's going to go up to +1. So for E, it's +1. And then the next one says going to -1. So if we say here we've got -1 from the negative side, and here we've got -1 from the positive side, those two are different numbers, so we know that this one's got to be what? D and E. Good job. Does not exist. Okay, now here's where the questionable one comes, where it says if x goes to -infinity, so in this case right here, x is going to -infinity, it's going to be going this way. So where are we going to be all the way down? We're going to be at -1 because this is a constant function. So this one's going to be -1. But now here's where the question was. This one, some people wrote +1 because they thought it was an asymptote across the top of that one. Some other people wrote +infinity as well. As x goes to +infinity, then y goes to +infinity because it looks like it's going out to the right. So we'll kind of let that be a questionable. If it's an asymptote, then my answer would be 1. If it's +infinity, then my answer would be infinity. So, okay. The next one is number 8. Number 8, again, is a graph. Let me move it down so you can see 8. Okay, it says use the graph below to evaluate the following limits. So the first one says as x goes to 0, and this one doesn't say positive or negative side. So we know it's got to be from both sides. Since they're not the same, then we know that that one's going to be D and E. The next one says as x goes to +infinity. So x going to +infinity is going to be this one. So all the way across, it's going to be 2. So that one's 2. And then x going to -infinity, then we see how it's going to be -2. Okay, now, anybody, what is this? Think about what this is. What kind of function is this? Piecewise function. Good. Piecewise because it separates up into different parts for the x. Okay, the next one, if you need a calculator, then you probably need to get a calculator for these. Hopefully not. Hopefully you can do these in your head. So evaluate each limit. So it's at a specific number. This one's -5, this one's 6, this one's -1, this one's 4. So the idea on these is to plug in first. Now, when I plug in, if I get a normal number, then that's my answer. So I'm going to substitute in the number -5 and see what I get. If I don't get a regular number, now by that I mean we have 0 in the bottom of a fraction. You can't have 0 in the bottom of a fraction. So then we would have to factor. So on this one, I'll put in -5 plus 2, -5 plus 7. So this gives me -3 over 2. So since that's a normal number, there's no zeros in the bottom of the fraction. That's my limit as x goes to -5 of x plus 2 over x plus 7. Now the b one, if I plug in 6, I get my denominator to be 6 minus 6, which would be 0. And the same with my numerator, I'd get 0 over 0. So we know we can't have that. So we have to factor. So I get 2x minus 6 over x minus 6. And the x minus 6's cancel out, which will come out to be a whole later. I'm not graphing these, so we don't really care, but this would be a whole. And we'd be left with the limit as x goes to 6 of 2x minus 12 over x minus 6 would be 2. So my answer would be 2. Okay, C, the same kind of idea. I plug in first, so I plug in -1. -1 plus 1 gives me 0 in the bottom of a fraction. So we know that that's going to be one I have to factor. So this gives me x and x. Factors of 4 would be 4 and 1. Since it's a -3, we know that 4 has to be negative and the 1 has to be positive. So again, you can see something that will cancel out. Again, that's going to be considered to be a whole later. And now I've got the limit as x goes to -1 of x minus 4. So now once again we plug it in. So -1 minus 4 is going to give me -5. Okay, so this one we're going to plug in first. So I get 16 plus 12 plus 9 over 1. So what is that, 28, 37? And so that would be my limit. So that was number 9. Number 10, we're looking at a graph again. So as x goes to -infinity of h of x, so this whole thing is the h of x graph. So we're going to consider x going to -infinity this time. So as x goes to -infinity, what happens? Then the y gets closer and closer to this -1. So my limit is -1. As x goes to positive infinity, so this way x is going to positive infinity this way. Again, it approaches that asymptote, which gives me a -1. Now we have x going to -2. So we have both sides have to be approaching -2. So we have -2 going up for fast. So we're going to have positive infinity. Okay, this one is evaluating limits at infinity. So we're going to take into consideration that infinity is a very, very big number, right? So certain things aren't going to make a difference. So the -4 and the 1 we can x off, and the -3x. So we're left with x squared over x to the third. But now you can see that an x squared can go out of the top and the bottom, the numerator and the denominator. So I get 1 over x. So this gives me the limit as x goes to infinity of 1 over x now. Now, if you consider the fact that the bottom of a fraction of the denominator, as it gets bigger and bigger and bigger, the fraction's getting smaller and smaller and smaller. And we're only plugging in positive numbers, so we're not going into the negatives. So this is going to get closer and closer to 0. So you can try it out if you want, like do 1/2, 1/10, 1/100th. What's happening is these numbers are getting bigger, the fraction's getting smaller, right? Dot, dot, dot. Okay, this one over here, the same kind of idea. We've got, this is going to x off. Then we've got the limit as x goes to -infinity this time. We've got x squared over x, so one of the x's is going to cancel, so I've got x. So the limit as x goes to -infinity of x would be -infinity. Okay, C says 2x squared minus 3x and 5x squared plus 1. So the 3x and the plus 1 don't matter. The x squared and the x squared cancels out, and we're left with the limit as x goes to infinity of a constant, 2/5. So my answer is 2/5. Okay, the last one on this section, these don't matter because it's minutely small when compared to infinity. So here we're going to have x to the third over x squared, which again, we can cancel x squared out and get x. So the limit as x goes to negative infinity of x would just be negative infinity. Okay, number 12 says, find the values of x for which f of x is discontinuous. State whether each discontinuity is removable or non-removable. So we said earlier we're going to talk about holes. Holes are where you have a graph where maybe it's graphing along and then all of a sudden it has an open spot and then it just keeps on going from there. So this would be a hole. And then we also have what we call asymptotes. So asymptotes are where the graph cannot be. So if I have a graph that does something and then all of a sudden has an asymptote, then we can't have that. So these are two things. Asymptotes are the non-removable and holes are the removable. Okay? So in this one right here, we're going to factor first. So f of x equals x minus 3 over x minus 3, x plus 3. X minus 3's cancel out. So again, there's where the hole is. So x minus 3 is where the hole is. So we get x equals 3. And we're going to just write hole. Now we'd have to come back and find the y. But right now we just care about the asymptote part in the hole. So this is going to be x plus 3 cannot be 0. So that says x cannot be a negative 3. So this would be our asymptote. And this would be our hole. Now the hole you're plugging back into the equation because you can't plug back into the original equation or you get 0 over 0 again. So you're plugging into 1 over x plus 3. So if the hole is at 3, then my ordered pair is going to be 3, comma, in this case 1 over 6. And my asymptote is going to be a vertical line going through negative 3 on the x-axis. All right, this next one is the tangent function. We're going to graph it from what we learned before when we were doing trigonometry. So we know that tangent x equals sine x over cosine x, right? Now, I would make sure that you knew how to graph those trig functions. So we know that the sine and the cosine on a unit circle, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. And this is the coordinates for 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to graph going both directions, 1, 2, 3, 4, 2, 3, 4. So this is 0. So sine over cosine. The y value is the sine, the x value is the cosine. So sine over cosine for 0 is going to give us 0. Next one is pi over 2. Sine of pi over 2 is 1 over 0. So I get an asymptote because we can't have 0 on the bottom of a fraction. The next one would be pi. So sine over cosine is going to give us 0 over negative 1, which is 0. Then we get 3 pi over 2. Sine over cosine is going to be, again, 0 in the denominator would be undefined. So we have the asymptote again, and then back to 0 again. Now we call this periodic function. So we've got dot, asymptote, dot, asymptote, dot, asymptote, dot, asymptote, dot. So now between each of these ones, this is a quadrant. So quadrant 1, 2, 3, 4. So quadrant 1, we know that it's positive, positive. So positive divided by positive is going to make this go up. And then the next one is in the second quadrant. We know that's going to be negative, positive, so it's going to go down. And third quadrant is negative, negative. Negative divided by negative gives us positive, so it goes up. And this one, fourth quadrant, is positive, negative, so we're going to go down. So, you know quadrants, positive, positive, negative, positive, negative, negative, positive, negative. And that's how we get these up and down. But again, if it repeats itself, it's down, up, down, up, down, up, down, up. So these are the negative values, and these are the positive values. So we can see that at pi over 2, 3 pi over 2, and the next one would be 5 pi over 2, and so forth, as well as going in the negative direction, negative pi over 2, negative 3 pi over 2. So we're going to get a solution that looks something like this. Pi over 2 plus or minus, because we're taking it away each time, pi, but we're going to do it all the way across the line, so it's going to be pi n, multiples of pi that you're adding and subtracting. So this would be my asymptotes. So we're going to say that this would be non-removable. So that takes us through the review for the limits. So we're going to be taking the test either Monday or Tuesday. So let me know if you have questions. Thank you. Bye.